Today we have an AP Calculus question from 2015. This one is question 4, part D, and it says that consider the differential equation dy over dx equals 2x minus y. We want to find the constants m and b, the values of those constants, such that y equals mx plus b is a solution to our differential equation. Now, at first glance, this doesn't seem that bad. We're just solving a differential equation. But then notice that we have constants, we have a few constants, and you might be comfortable with working with constants, you might not be. I always just think of constants as just numbers that we don't really know exactly, and here we're trying to find the value, so we will know at some point. But the thing is once you get into the problem, it gets kind of weird, so let's just get into it. So what we start off with is the fact that dy over dx equals 2x minus y. And the way you can work with that by also using the fact that y equals mx plus b is to just think of it this way. So you're going to take dy over dx, so d, and I'll put y in red, so dy over dx is going to be equal to 2x minus y, so 2x minus y. And then we also have that y equals mx plus b. So we can simply just plug that in. So this information tells us that we're taking the derivative of mx plus b, so mx plus b, and then this is going to be equal to 2x minus mx plus b. And so basically from here, we can just start by taking the derivative here. The derivative of mx plus b might be a little weird because, again, we have the m and the b as constants. Just think of them as numbers. So b, if b is a constant, the derivative of a constant is 0, and so that goes away. The derivative of a constant times x is just that constant, so in the end, we're just left with m. m is equal to 2x minus, and now we're going to distribute the negative sign across the parentheses, so it's going to be 2x minus mx and then minus b. Okay, so then what we can do is just factor out the x. That's kind of a standard step in solving things. So we take m equals, so this is going to be 2 minus m x and then minus b. And I kind of made this weird. So then the thing is how do we actually proceed here? Because we're trying to find m and b, but at the same time we don't really have a way to solve for anything in terms of just simply numbers. Anything that we try to solve will be either in terms of m or b or x or a combination of this. So it gets kind of messy. So what we can think of doing actually is thinking of this other side here as 0x plus m. That way, then we have two things to equate to. We have this 0 with this 2 minus m, because they're related by the x variable essentially, and then the constants are m and negative b. The reason why you might do this is because you can think of the constants as being their own thing, and you have like a sort of system of equations in this particular way. And remember that whenever you're dealing with differential equations and you have these constants, they're usually constants of integration, and those always can change. And remember that derivatives of constants are 0. So really, in this case, constants don't necessarily matter. And we can kind of do things like this, which kind of comes out of the blue, but that's the way to solve it. So we'll just move on kind of with this assumption in mind. So here we take 0 equals 2 minus m as our first equation. And then the second one is m equals negative b. Okay, so I equated this with this, and then this with this. And that's how I found these two equations here. So this immediately tells us that m equals 2. So we found m there. And then this tells us that m equals negative b, so that means that b equals negative 2. And that is the solution to the constants of our differential equation. So hopefully that kind of made sense. I know this last part was a little strange, but just kind of remember that when we deal with constants with differential equations, things like this will be able to happen because we don't really worry about constants because they can just vanish at any moment. But yeah, hopefully you enjoyed. If you still have any questions, let me know in the comments. So thank you so much for watching, and I'll see you in the next video. Bye guys!